All right. Yeah. So I did some research in using so-called big data, and the implication for big data is smart tourism. However you define smart tourism is. So many of the studies are based on my research in tourism places such as Charleston, South Carolina, and also recently national parks in the US. Because I moved to Penn State, then my research direction slightly changed to more to national parks. Let's start with my website. So this is my website, right? I have my biography, I have my teams, I have my publications, some pictures of me. I put up this online, and so it shows the world who I am, right? So students who are interested in studying with me can check out my website. Okay. I took a look at my analytics from my website. So I can see how many visitors from South Korea. Actually, not too many. So last year, we only have 24. But that slightly increased from the year before, which is 21. I have a 15% increase in audience from South Korea in a year. I don't know. I don't think that's a huge amount of traffic volume. However, I can see the trends, right? There may be more interest in my research from South Korea. If I look carefully, I even can see from which city these visits are coming from.
Okay.
I may say, okay, that visit from Kyunhee University, actually I can see that. Moreover, if you look carefully, you can actually see which web page the audience are looking at.
Oh.
My homepage, my team page, my publications, my courses, the courses I taught, the pictures, the words, etc.
Oh.
So you can see the number of visits from different pages.
Oh.
If I really want to do this, I can actually see, let's say yesterday, the IP address from Kyunhee University, which paper they're looking at on my website.
Okay.
Because I can set up certain cookies on my paper that I can check the IP address from this university, how many people come to see my paper, which paper they're looking at.
Okay.
I didn't do that, but supposedly I have a capacity to do that. So I think that's significant. So that means I couldn't know my audience, you guys, before you see me on the computer screen. Okay, so think about that. I already know something about you even before you see me on screen. So that's the power of analytics. So you can check who's visiting your website from background to understand your potential consumers. In this case, you guys are my consumers. You listen to my talk, right? How did I do that? Because my website is in PSU server. When you are visiting my website, your browser or your computer send your IP address, sometimes your hardware information, your software information to the server. So I put a little cookie on your computer, a small, tiny file with ID number on your browser. So if you come to visit my homepage again, I can see that the same cookie. So this way, I can keep checking who's looking at my website for how long, for how many times, and which page they are looking at. So that's one thing we need to remember first. In the online world, everything is bi-directional. Whatever you do online, use your mobile phone, visit a website, go to search engines, there's always two-way communication. When you type in a query in Google, Google is keeping a record of your search query and your IP address too. When you're visiting my homepage, my website keep track of your IP address and where you're from, because IP address can be translated into domain names. Domain names indicate your location. So in the online world, everything is bi-directional. You're looking at something else, something online, something is looking at YouTube, okay? So remember that. So that's important for us to understand the potential of technology. So why is that's the case? Just because we have more and more fast computer, we have more storage space, we can afford to store all the information in our server, okay? That's come back to our, Moore's law. Moore's law saying that our computer speed gonna double every, 18 months. Because we have so much information, we always store them because hard drive getting cheaper, computer speed is getting faster. Why not? Why not capture all the information available? So that's the Moore's law. That determines we have more and more data. We can afford to keep record of all the pieces of data available. Now, Michael Porter was talking about the fourth paradigm of computing. The first paradigm is mainframe computer. You guys may not familiar with that because you're too young. In the past, when I was in college, we have access to one computer from multiple people. So a lot of people access to one computer. Then we have the client server structure, the website structure. Now we have social network in terms of Facebook, Twitter, Instagram. Now we are in the fourth paradigm, the connection of intelligence, because all devices can get smarter. Your car is getting smarter, my TV getting smarter, my refrigerator getting smarter. So that's why in the fourth paradigm, that's made possible because of Moore's law, because we have fast computer getting cheaper, getting more and more storage space. So that means we have more and more data. That means we are in the big data era. But think about how do we do travel? If you go to somewhere to travel, say go to Seoul, and you had to go to Google or Naver, right? That's search engine in Korea, Naver. You had to go to the search engine, type in keywords, search for where to visit in Seoul, or you use your mobile phone to locate your position and say, where do I go from here? Then you post social media online afterward, on Twitter, on Instagram, to show where you visited, right? Of course, you are visiting the city, and there's cameras everywhere. So all this data can be captured. Remember, I can capture your visit to my website, and all this data can be captured, can be stored, can be analyzed. And that gives us some idea about who the tourists are, who are visiting my city. How do I reach them, right? So today we talk about search engine, web analytics, we talk about social media, some mobile phone data, how those data combined can give us a better picture of who our tourists are. And more importantly, if you think about this, sometimes you access different technology in different stages of travel. More likely you search for information pre-trip at home, right? Then after a few days, you arrive at the place. So there's a lag there. So with that lag, you can do interesting things, say forecasting. En route, when you travel to the city, you do other things. You use your cell phone, you locate your position, you find out where to go, right? After you get back to home, then you write a review on Twitter, on TripAdvisor, and those information can influence the next tourist. When they see your positive review or negative review, they will decide whether or not to come or not to come. So you can say this is a loop. So basically, if we have some data to be the precursor to travel, means it happening before the travel, we can do forecasting, for example. We can do interesting things with those data. So today we talk about forecasting. I'll talk about forecasting, monitoring using big data. Then I will talk about challenges and we're facing with big data. It's not all about these rosy pictures of big data. Sometimes there's the dark side of big data, the messy side of big data. Okay. We talk about the website data, search engine data, social media data, mobile phone data, and lastly, I'll talk about simulation data. This is a new project I'm doing with my students in Rocky Mountain National Park. So all those can produce massive amount of data. Search engines. Are you guys familiar with Google Trends? Anyone? Yeah, a few people know Google Trends, right? So Google Trends is a website where you can see the search volume for certain keywords. Can you see my screen now, or can you see my Google screen?
Not yet.
All right, so let me share again.
Okay. Good.
This is a search query for Seoul, Korea.
Mm-hmm.
In the last, from 04/2020, you can see the trends here.
Mm-hmm.
You can see there's a big drop starting here at 2020. Maybe it started COVID, but I'm not sure why there's a peak in February 2018.
We have met North Korean President Kim Jong-un.
Oh, that's why. Wow.
With Trump.
Yeah.
I guess. Yeah.
Yeah, something going on in February 2018, right?
Yes. Right.
And you can see all the search from US, like that's Hawaii, because I guess it's closer, right? California is closer, and Washington State is all West Coast. Alaska is maybe it's closer to. So you can see, BTS. You see a lot of people search for BTS.
Okay.
In relation to Seoul. So, yep. So this is an indicator of interest. When people search for Seoul, Korea, more likely they may be interested in learning about the Seoul, or maybe even want to travel there, right? So that's why it is an indication of travel intention. Think about that, right? If you go to a foreign country for Americans, right? If you go to Seoul, they had to do some research first. So they go to Google to type in a query. So that query was captured by Google, and Google can calculate how many times people search for Seoul. Because they know your IP address, they know where those searches are coming from. They know search from California or Hawaii or Alaska. So that's such query. So, and back in 2010 or 2011, there's paper published on Science or Nature. They're trying to forecast the flu activities using Google searches. The hypothesis is if you're getting sick with flu, you're more likely to go online to search for, say, how to cure flu, what are flu symptoms, how to cook chicken soup, for example, because if you believe chicken soup are good for flu, right? So Google scientists using 40 different keywords trying to predict flu outbreak. Why? Because they know your address. They know where your searching coming from. If they know there's searches around, say, Washington, D.C., then there's more searches from Maryland, then they know that there's flu outbreak about to happen. And that's important because in the past, people forecast flu outbreak using CDC report, the Center for Disease Control report. Center for Disease Control is based on office report from doctors. I mean, doctors' report this case is already happening. So that's actually after you search for information on Google. That's why it's late. So using search query for flu activity, they can forecast flu activity 3 weeks earlier than CDC report. So that's significant, right? If you know there's outbreak in certain places, you can accumulate more drugs, for example, or more medicine. So you can prohibit, you can deal with the situation better. So I think that's the starting of big data research in my view, in 2011, I think, around 2011. The starting was, search engine query research on forecasting. So why not doing this with search for tourism, right? So first question I'm asking is, can we forecast hotel occupancy using search engine volume data? Because we know a tourist will be likely to search for the place before they go there, because if we can figure out how the amount of searches, then maybe you can forecast the future hotel occupancy. And we know forecasting hotel occupancy is important for hotel managers. Then they can set up appropriate, pricing scheme. If they say there's higher, lower hotel occupancy in the next month or next week. So the question we're asking is, can we forecast hotel occupancy with search engine data? Now, the assumption is people will search before they come to this place. So we use SPR. Yeah.
I have a question. I'm sorry, I'm talking to you, but
yeah.
I want to hear from you about this pandemic situation. You use that Google forecasting about the like virus and the flu forecasting using our Google search engines, which is become popular case right now, and we are in the middle of the pandemic now, and people are focusing now ending of pandemic. So what do you think the Google search engines can be able to forecast the end of the pandemic at this moment? What do you think? That's my just curious question.
Yeah, that's a great question, right? I guess search is more about interest, right? And think about what kind of keywords are indication of pandemic?
Probably keyword like when is going to be end of the pandemic or COVID-19 disappear, whatever.
I think that's more like the indication of a wishful thinking. I wish this pandemic can be over. I'm so tired of this. But whether or not the pandemic can be over, I think that's a different story.
Okay.
Right.
This is a different story, right?
I think that's more about our motivation, like travel, right? We go to a place, we want to go to that place, we search for keywords. But that pandemic, I don't know, maybe there are some keywords, Okay, so the question is, can we forecast the cases of pandemic using such keywords? For example, maybe people getting sick, if they're dying, they go to search engine first, maybe, maybe that could indicate the cases, that could be the case.
However, it's wishful thinking is not possible, I guess. But before COVID or at early of COVID period, probably people are search some keyword about their symptom.
That's right.
COVID-19. So probably there's something happening ahead of us, and then actually happened to COVID-19. So probably 2018, late 18 or early 19 or early 20, probably there's something search engine keywords about like what the flu the case.
Yeah, I think that's a great idea. Yeah, imagine there may be some, suddenly the searches, a lot of searches about the flu from Wuhan, than from nearby province. That means, yeah, the indication of spreading. If we're smart enough to pay attention to that, then maybe we can, can turn the pandemic. You're right. Yeah.
Okay.
Yeah. Yeah. So then in China we have to use Baidu index. It's not a Google Trends now. So Baidu has different, very similar product called Baidu index.
Okay.
So Google is Google Trends. Baidu has Baidu index. I'm sure Naver may have different, similar product. I'm pretty sure, because they copy each other.
Anyway, okay, go. Sorry.
Yeah. So I think I can jump around a little bit. So basically, the idea is we can use hotel occupancy. We can use the search engine volume data. We try to find the correlation, and we try to forecast the future hotel occupancy. We get the hotel occupancy through STR. I'm sure STR. I think Korea has STR company too, right?
Yeah.
So STR is a company in the US, Asia too. They provide hotel occupancy data. Then we get the search engine volume data from Google Trends. We try to correlate the two different data sets. We use some data as training set. We use the other part of data as validation set. We use only 5 queries. Okay, this is what one city in the U.S., Charleston, South Carolina, Charleston SC, Travel Charleston, Charleston Hotels, Charleston Restaurant, Charleston Tourism, because that's the most common used keywords for searching for a place. And when we map out the search query, we can see actually there's very similar peaks and valleys here. There's dip here, there's dip here, there's dip here too. So because the numbers on the bottom is search query, the line on the top is hotel occupancy. You can see they follow similar trends. So we found out using 5 keywords, we can increase the forecasting accuracy by 2 or 3%. Well, you may think, what's the big deal? 2 or 3%. But if you can increase accuracy, that's valuable for hotel managers. And we found out 4 to 8 weeks is the ideal lag. So for today's search query, somehow can forecast future 4 to 8 weeks of hotel occupancy. Now that means for this city, people usually plan ahead 4 to 8 weeks. They start planning trips 4 weeks ahead of their actual travel.
Okay.
So that means that the behavior, if we know certain behavior, we want to use that information to forecast future hotel occupancy. Okay. Good, fantastic. So search engine query is useful for forecasting because that's an indication of travel intention. How about web traffic data? Because when you are searching for information, you want to go to a website to look at the information, right? So what about the Tourism Bureau's website data? Let me see if I can display this for you. All right, so this is the website's analytics for my personal homepage, right? So you know what? Let's see the real time. 0 people, okay, 0 visitor on my website right now, but you could see I can set up a way to take a look at the visitors in the last month, in the last week. Here's the visitor volume from last week. I can change the parameter to look at last year. So there are a few peaks. I have no idea why. Maybe I'm giving another talk somewhere, Yeah. So here is people's visitation to my website. It's only 1,000 visitors. It's not a lot, Nothing compared to Chumo's website, I believe. So, yeah. Right. So here's my information, and I can see where people are coming from. US, of course, first, and China, UK, India, South Korea, Hong Kong. Right?
Okay.
All right. So if we believe such query is useful, I mean, website traffic had to be useful because people always check out the tourism bureau website before their travel. Okay. So we did another study. Means can we use tourism bureau's website traffic to predict future demand for hotel rooms? So we use STR data again. STR provides the hotel data. We use the Charleston area tourism bureau data as the website volume data. We use visitors versus visits. Visitor means one web browser. Visits means one visitor can visit this website multiple times. So visits always bigger than visitors. When we graph the numbers, you can see the up and downs are pretty similar to each other. So the top ones are the website data. The bottom ones are demand measured by room nights, or occupancy rate, means 1 to 100%, right? 0 to 100%. So again, we found out 4 weeks ahead of forecasting, we can improve the accuracy by 14.5%. Okay, this is pretty good. It's even more useful than search query data. Remember, search query data can increase accuracy by 2 or 3%. Now we have 40% increase. Meaning that that means the website traffic may be getting closer to actual visits. So it's a better indication of the the travel intention. Why? Because people search for Charleston SC. They could be interested in studying for the city, because Charleston is a historic city. They may search for the city because they want to study what's happening in Charleston in 1800, because there's Civil War history there. So the web traffic is a better indicator of travel intention, because that's really about tourism information. All right, so we validated the value of web traffic data for predicting hotel demand. So the idea is, why not post those traffic online so the local hotel manager can see that, right? Because we suppose it's useful, hotel manager want to see that. Only the internal people can see the traffic volume for the tourism website. I mean, why not post them publicly, right? So the tourism bureau can be more useful. And we showed 4 weeks is a planning horizon, means the plan trips 4 weeks ahead. Well, that's for Charleston, South Carolina. It's maybe a different story for different cities. And I assume the planning horizon is going to be getting shorter in the future. Because we have more access to technologies, we have cell phones nowadays, we can plan trips in very short period of time. Okay, good. So website traffic is useful. Search engine query is useful. So then we saw many data in the many research published later. People did research on Baidu. They found out Baidu can help forecasting Hainan province visitor volume by 80%. Hainan, that's the wrong spelling. Not Hainan province. It's an island in China. And also Baidu keyword search can improve some palace forecasting, visitor forecasting. Some palace is a famous attraction in Beijing. So Baidu index can help forecasting their visitor volume. So it's useful for both, US cities, Chinese cities, Chinese province, and also a specific attraction. So the big data are useful, basically.
Here's my question again.
Yeah.
Like when you have done your research about web forecast,
yeah.
at the time is web. Still, web is essential and very necessary one. But however, the trend is like when you said we're changing to the YouTube, even TikTok, mobile. So a lot of young generations probably prefer to use mobile and TikTok sort of things. Is it possible to research on the kind of traffic data in these days? They are all commercial companies. It's hard to get the data from them.
Oh, that's a great question. I think YouTube is part of Google,
Mm-hmm.
and I think Google Trends include searches on YouTube.
Okay.
So I think their query volume include searches on YouTube. If you search for Seoul, Korea, that part of volume is included, I think.
Okay.
I'm not sure about TikTok though. I don't know they publish any index from their apps. You're right. I mean, they're a private company. I mean, their information are private, and they don't have to publish those data like Google. Google does not have to publish the data. They just found it's useful, and they publish the data. So that's a great question. So I don't know. So yeah, go ahead.
I mean, so anyway, a lot of the marketing, channels are moving toward, mobile, especially like a TikTok and the YouTube. A lot of people, young generation is getting shorter and shorter, image and then that kind of stuff, more preferable to them. So anyway, so we have to take the kind of data from those channels and how they, changing their preference and sort of things. But it's very hard to get the data.
Yeah, I mean, you're talking about that's. We'll talk later about the messy side of big data. So that's the messy side of data because it's always changing, and the model works today, it may not work tomorrow, and it's changing so quickly. Today is Google, tomorrow is TikTok, next year I don't know, maybe there's new platform coming up. So I agree absolutely. I mean, nowadays people don't even search anymore. You can talk to your smart speaker, right? So you just say, Siri, tell me about the flight to Seoul, right? So it's not in the Google search volume anymore. It's about your interaction with a smart speaker. You're right. But the question, how do we capture those volumes, right? Yeah. Okay, so let me talk about the use of big data for different purpose. We just talked about forecasting tourist activity. Here's another job we're doing for the Tourism Bureau. How do we find out the potential markets for a place? Because this study was done by my students, So-Young Park and me a couple years ago. And now So-Young Park is a professor at Florida at the Atlantic University. So Charleston, Charleston has a very historic. Actually, it's expensive place because they keep the tourism artificially low. They don't want a lot of tourists. They want a high-end tourist. So it's a pretty expensive place. They control the growth of tourism. The Tourism Bureau's job is to increase volume to this place. And one bottleneck for Charleston as a city is the flight is so expensive because they don't have many direct flight to the city. Once you don't have a lot of direct flight, and people will say, that's too much trouble to fly to that city. It's too expensive. I won't go there. So one job for Tourism Bureau is to attract budget airlines, like the cheap airlines. if they can convince the cheap airlines to fly to the city, if your travel cost is lower, you'll say, that sounds fun. Let's fly to Charleston, because now we have flight there in 2 hours. So the tourism bureau approached us, say, which city shall we open a flight? Tell us, it's Atlanta, or it's Charlotte, or DC, or Boston, or LA, which city should we fly to? So we can generate the max amount of benefit for tourism. So the process for this question. So so we're trying to solve this problem. So that's Charleston. That's all the flight they have. So, but this is not a lot of flight. So that's why it's pretty expensive place to fly to. Okay, I jump through this. So I'm not sure. I think you know what gravity model is, right? I mean, that's in high school or middle school physics. So gravity model says the attraction between two stars or two heavenly bodies is determined by the mass of the stars and then divided by the distance in between. Right, then you have G. G is a parameter, determines the gravity. So G is the parameter. A is the mass, and the distance is in the opposite direction. A lot of people using gravity model to do research in economics, because a lot of the phenomena follow this gravity model. How many trades between two countries is based on gravity model. That's why Korea, Japan, and China have a higher trade volume because the countries are close to each other. And the bigger the country, the more trade between the countries, right? So it makes sense. So it's positively correlated with the size of the country, negatively correlated with distance. And people did this in tourism too. So the volume between two different cities or countries too is positively correlated with the size of the country, the size of the city, and negatively correlated with the distance. So in Korea, you're more likely to fly to Tokyo or Beijing instead of say Washington DC, because it's too further away. So gravity model used in tourism. So we try to build this gravity model for Charleston, South Carolina, this city, because we're going through this funnel. When you try to go to the place, you have to be aware of the place first, and you do some research about the place, then you make a decision on place, then you go, right? And in different stages, there are different big data or small data to represent those stages. In awareness, there may be, you can do this using surveys to get to know how many people know about the city. When you do research, right, then you can see the search volume. That's when they're in the research stage. If they can make a decision to travel to that place, then you can get the information through, say, airline reservations, hotel reservations. So at each stage, you have different data to representing different stage. And all this data follow this gravity model, right? For example, we have all the cities around this specific city in the middle. How likely the people going to travel to the city depends on how big the dot is, I mean the size of the city, and how far away it is. So the bigger the dots, you have more volume travel to the place, right? And the further away, you have smaller volume to the place. However, as you can see, this volume is getting smaller as you reach the city. Why? Because there's the barriers there. The barrier could be too far away, or it's too expensive, or there are not so many flights. So I don't want to go there, even though there's potential to travel to the city, but there's many barriers. So finally, we can model this gravity using those data: the size of the city, the distance in between, how expensive the air flight is, and whether or not they have direct flight. So we build a gravity model using those variables. We put all the variables into this model. So the y, the dependent variable is the volume. The independent variables are population, GDP, per capita. It means how expensive it is. Then we have a flight. We have cost. We have flight time. We're assuming the longer is flight time, the less likely they come to visit. So we build this model, and we use multiple type of representation of tourist. One representation is hotel room night sold. Another one is number of flight passengers. Another one is mobile devices. We have the mobile phone data to figure out how many people come to this city, to Charleston, South Carolina. Another one is web traffic. Remember, web traffic is not actual visitor. Web traffic is indication of interest, because they're searching for the place. All right, so we built this model. For example, we have this this line here. That's the fitness model, and we found out some cities it's overachiever, because according to this model, this place is supposed to have, say, 10,000 people come to the city. Actually have 20,000 people, so it means that overachiever. Some cities are underachiever. You know, for example, this one should have 1 million visitors, but they only have 500,000. That means they have a lot of potential. There's a gap here. Our job is to find out all the cities with potentials. And those potentials means they may not have direct flight. Actually, we figure out the parameter for the direct flight. So if you have flights fly there directly, you can increase the volume by certain percentage, because that's one X variable in the equation. So by doing all this, then we compare with the website traffic. See, this city have a lot of potential, and you know what? They have a lot of web traffic. That means you have a lot of interest, but not people come to here because of no direct flight. So let's fly to that city, because that city has the potential and a lot of interest, but we're missing a lot of real visitor from the place. So we did this formulation, this regression. I skip all the formulas. You know, I know those are boring, but it came from our hypothesis. So flights is increase volume, population increase volume, distance is negative, flight time is negative. The more flight time, the lower the volume. So we finally figured out those cities that we could fly to: Portland, Maine; York, Pennsylvania; Lancaster, Pennsylvania; Evansville, Indiana. We even figure out if you have a flight there, you're gonna have 500 people per week. Because we have a large web traffic from that place, and they have a lot of population, pretty high income. If you're driving, it takes 17 hours. If right now it takes 4 hours. If you open a direct flight, you can save 1 hour, and you have a lot of traffic. So they need a flight to Portland, Maine. So basically, so all of these are from our research in gravity model. We found out this model. We found out the places with potentials. Well, you know what? The airlines did not follow our advice. So we say you should fly Portland, Maine, but they never flew to Portland, Maine. They flew to Atlanta. They flew to Denver. They flew to actually London. They opened a flight to London. So that's interesting, you know. So why they did not follow our advice? My interpretation is they have different thought process. They have different decision-making process. They have considered their structure of the airlines. You know, sometimes they have the spoke hub structure. They have to consider which one have the hub. Is the hub the flights? And also, they want to steal market share from other airlines instead of open a new airline to a different city, unknown city, right? Because there's a risk there. It's rather to steal market share from other airlines if they're a cheap airline than open a new airline to a different city, because it's less risk. So my research is based on the benefit of the local tourism. Well, the airline may not care about your tourism. I only care about fill my seats on the airline. I don't care about this new market, older market. If I can fill my airline seats, I will do it. So that's the lesson I learned. So my research, I think, is valuable, but they didn't accept our research. But that's okay, you know. So I think we did a study for the tourism benefit, the benefit of tourism for the city, not necessarily for the airline. But the study is useful, shows the value of big data, right? So web traffic is an indication of interest. If you have a lot of interest, less real visitors, that means there's potential there. And you have to figure out how to convert those potential visitors into real visitors.
Okay. Here's my questions.
Yeah.
It's very interesting. You applied a very interesting theory for your research topic, gravity theory. So gravity is the heavy, stuff is dragging to each other.
Yeah.
Depends on their weight, right?
Yeah.
So my idea is, I think is, if the big city like the New York City and Los Angeles is a big gravity each other.
Yep.
So probably there are huge they commute to each other and number of people visiting each other. That's gravity theory, isn't it? Right? But when we choose a place to visit, it's like when you're finding on is a direct flight.
Yeah.
And rather than indirect flight. But travelers are highly interested in finding out the point of interest, like a Grand Canyon.
Yeah.
But Grand Canyon is isolated place.
Yeah.
Not the direct flight.
Yeah.
So people, my case, I want to go to Grand Canyon, but there's no direct flight.
Yeah.
But anyway, my point of interest is I want to go to the Grand Canyon. That's the point of interest, much higher gravity than the direct flight. What do you think?
Yeah. Wow. Yeah. Good questions. You're talking about something beyond the size of a city, right? You're talking about the value of attractions.
Yes, that's the travel gravity. Travel gravity.
Yeah.
The attracted by the POI. Yep.
So basically, that maybe you can solve the value to the attractiveness of the place. Say Grand Canyon, you can say there's 100 because everybody knows Grand Canyon is so attractive, it's beautiful. Mm-hmm. And you assign, say, 90 to Yellowstone. Yellowstone is famous, Mm-hmm. And you assign 50 to Las Vegas, right? Mm-hmm. Mm-hmm. Yeah, there's a way to do that, I believe, yeah.
So my question is like, direct flight is they design, the flight companies like American Airlines designed for direct flight depending on the commuters, number of commuters between the city to city.
Yeah.
But travelers, we are not the citizen of the travelers is not the citizens.
Yeah.
The citizens usually prefer to go the place by time distance and the cost distance or something like that. But travelers is we want to look for the very charming place to go visit.
Yeah.
So probably my point of interest is not the similar with the airline companies. They design the route.
Yeah. Very good. Yeah, I think so. Yeah, I think you're right. I think I learned about this. I did a study on this. I did a study in the airport of Charleston. So half of their visitors, half the traffic is local residents. Mm-hmm. Half are tourists. Mm-hmm. So basically, so we survey the people in the airport. So when they're waiting for the flight, you're right. So more than half, maybe around half, are local residents. They fly out, fly in. Yeah. So again, you're right. So because we're doing the study for the benefit of Tourism Bureau, mm-hmm. we're doing this not for the local residents, right? Mm-hmm. So we're saying, okay, if you open this flight, that's going to benefit tourism. Mm-hmm. And the airline will consider other factors, like say, some people may go to Charleston for business, and Charleston people can go to LA or New York for business. You're right, yeah. So that's another reason our model did not work. Yeah, mm-hmm. You're right. Yeah, that's a good question.
Yes. So yeah. Once again, my argument point is, people want to visit POI, point mm-hmm. of interest, rather than the big town. Yeah, big town is one place for visiting. But if, the direct connecting, or if a place, if their transportation route, probably people can be able to visit more frequently or much more than they now. So the gravity theory is important, but however, we can make another adaptive gravity theory for tourism context rather than transportation itself, but the tourism, purpose.
Yeah, I think I read some paper on that. So they measures the attractiveness by the number of historic sites or number of 5A areas. In China, there are 5A scenic areas, or number of World Historic Sites. I think World Heritage Sites. Mm-hmm. They measure by you can give a weighting to that, and yeah. But again, I agree. But however, city also have a lot of attractions,
Right.
Like New York have multiple attractions,
That's right. Yeah.
So is LA, so is Boston. Mm-hmm. Yeah. Right. So maybe you can, yeah. So you're right. In this case, we didn't consider how attractive the place is, right? Mm-hmm. There could be a measure on that. Yeah. That's like another kind of power to grab you, to pull you over because it's so attractive. Just like, Las Vegas is attractive, yes. Even though the city is not so big, but, it's center for gambling. So
yes,
you're right. Yeah. But in this case, it doesn't matter for our case, at least, because we have one variable, Charleston. It's constant, right? It's constant. Mm-hmm. There's only so many attractions in Charleston. It's not it's not a varies,
Okay.
Okay. So do I have enough time? Maybe I'm going too slow, right?
You still have 30 minutes.
30 minutes?
30 minutes Q&A.
All right. But I want to leave some time for questions.
Okay.
Oh, by the way, if you have any questions, you can always ask, okay? I mean, for other students. All right, I jumped through this social media thing. Yeah, so how valuable is social media data? You know, I know we look a lot at review sites, because that's another type of big data. There's TripAdvisor in the US. There's Dianping in China. If you know Dianping, really how valuable it is. So we did a study in one of the cities in China, which is in Haikou, in Hainan province. So in this case, we crawled all the reviews from Dianping for these 29 restaurants. We also did interviews in those restaurants. Okay, we did a really on-site interview when people are having dinner or lunch. Now we compare the two different data sources. We compare review ratings versus the survey results. We found interesting results. Okay, so overall rating. So those dots are 29 restaurants in Haikou, and the x-axis is survey results. The y-axis is rating from online reviews. So for overall rating, the correlation is zero, almost zero. No correlation at all. So what people are saying online is totally different from the survey results we did in the restaurants. The same thing with taste. You can see there's nearly no correlation. What people are seeing online is totally different from the data we collected in the restaurant. For atmosphere, like how do you feel about this restaurant in terms of atmosphere? There's a positive correlation. Maybe R is 0.4. You can see the line here. For service rating, there's a positive correlation, 0.4. Its significance is at 0.005 level, so it's kind of significant. So that's interesting, right? So we trust social media, we trust review sites, but our study shows it's only useful in certain degree. It's useful in judge the service quality, it's useful in judge the atmosphere, but it's not so useful in judging the overall rating and the taste. Okay. So how do you make sense of this? Well, it could be because online reviewers are different type of population. We know they're more younger, they're more educated, they have higher income, right? So people who read review online are different from the population who actually dine in the restaurants, right? And taste is very subjective, right? And like taste, like my wife is from Hunan province. She enjoys spicy dishes. I'm from Shandong province. I don't enjoy spicy dishes. It's too spicy for me. So we have different evaluation for same dish. So that's caused all the insignificant correlation. So big data may be useful, but only partially useful. So that's our conclusion. I'm sure Chum will have different opinions. Think this maybe other reasons cause this, right? Maybe different timing. We did a survey in different time versus what's happening online. People write reviews in the past year. We did the survey this year. The restaurant may change. So. All right. Social media useful, not useful, partially useful. Social media useful in study nature-based tourism. This is about national parks in the world. Social media, like the posting pictures, is correlated with visitation to those parks. Okay, you can see this line here. It's correlated, not so much. You can see the wide range of correlation. So all the dots are different national parks in the world. Okay, they correlate the picture posted versus the visitation to those parks. Yellowstone. So we started Yellowstone on Twitter. We found out why people are posting on Twitter. You can see those dots are the places posting on Twitter, because some tweets carries their geolocations. We use their Twitter profile to figure out this person is male or female, and we compare with surveys. Okay, we also have a survey result inside Yellowstone. You can see the female and male ratio are very similar, almost the same. That's good. But in terms of the seasonality, so here is visitation in the real world, the real stats in the park. So the blue one is the tweets, the volume of tweets about Yellowstone. Well, so in the winter there are more tweets, but there are less visitations. Okay, so in the summer there's more visitation but less tweets.
Why?
Why? Yeah, why is that?
Because winter is cold. So nothing to do, just tweeting.
Yeah. Well, I was in Yellowstone in the winter. You cannot actually go in, like buy a ticket to go buy ticket go to Yellowstone. You have to take the tour. They have those big trucks. You have to sit on the big trucks. You cannot drive the car because the road is covered in snow.
Yeah.
So no way you can get in Yellowstone in the winter. You have to rent this big truck. You know, you have a tour company to bring you into the park. So very few people.
Yeah.
However, it's beautiful, absolutely beautiful. I love the Yellowstone in the winter, even in the summer, because it's like you know, it's like it's all everywhere is white. You know, it's really beautiful. That's maybe because why people tweet more, because I enjoy the winter. It's less people. It's more animals. You actually can see some animals. So, yeah, and the demographics also very different. So the people tweeting about Yellowstone are younger on Twitter. Real surveys shows people are older. So that means this platform bias. So people are tweets are biased to population. We also can figure out the ethnicity of the Twitter user. How do you do that? We use some machine learning methods, because many Twitter users have their picture, the profile picture. So Google Vision can tell you by your picture, you're Asian, or you're white, or you're black. So we can use that algorithm to figure out the ethnicity of the Twitter user. So basically, we found out, so in the survey, there are almost no Black people in the real visitors. Actually, there are 10% of Black people tweet about Yellowstone. That's interesting. So I can talk about more about ethnicity problem in national parks in the U.S. That's a different topic. So yeah. So basically, Black people have a lot of barriers to go to national parks. Culturally, historically, so that's a big problem in the U.S. Yeah, so again, Twitter is useful in some degree, can represent the behavior of the visitors to Yellowstone, but it's biased in certain ways, ethnicity-wise, age-wise, or the seasonality-wise is biased. So far, you maybe understand, there's good things about big data, the bad things about big data. Big data is always messy, it's biased, right? I jumped through this. Right, mobile phone data. I'm sure you saw this, those research before. I think there's a lot more research in mobile phone data in Korea, Asian countries, than the US. Okay, so people did the research. So so where this country? I forgot. Chumo, you must know this country, right?
Latvia?
Latvia, yes, Latvia. Estonia. I'm sorry,
Estonia.
Yeah. Ahas. I'm sure you remember Ahas, right?
No. I visited once Estonia. It's a very good country.
Yeah, it's a very good country. Yeah. So Ahas is professor in Estonia. So studied people's visit to Estonia by cell towers, because cell tower knows the origin of this cell phone device. They know this cell phone come from Russia. So they can capture all the Russians' visitation to Estonia, where they went to, different cities they went to, and he correlated with the mobile phone traffic with hotels. He found out they're very much correlated. So, yeah, I think Professor Ahas, he worked with a cell phone company in Estonia to get all the cell phone data. And that data is very hard to get in the US because different privacy laws, different legal issues. So, I think you maybe have seen this research by Sangwon Park. Dr. Park is now is in Korea. Which university is he right now?
My school.
Oh, Kongi University, fantastic. I'm sorry. Yeah. Yeah, so Dr.
It's doing well.
Doing well, yeah, it's great. Yeah. Yeah, Dr. Park used cell phone data, they studied from different countries. Because we know that this device came from China, from Japan, from US, because those are the roaming service, right? You can see this phone is in roaming service because it's from China. So he studied the different behavior, different places visited for Chinese visitors, for Japanese visitors, Americans, people from Holland. You find out different visitors have different patterns of visitation. You can cluster those places by 1, 2, 3, 4 different regions. So yeah, I think someone. That paper got some award, I think, right? The best paper award. You enter?
Yeah, he received the best paper award of the year.
Yeah.
In enter.
Yeah. Yeah, we also use mobile phone data study Yellowstone. Again, this is about Yellowstone. So we obtained a mobile phone data set. So this data is different from Dr. Park's data. Dr. Park using cell phone tower data, but we're using the opt-in data. So for example, if you download a weather app on your phone, sometimes you click OK, I agree to be tracked. In that case, the app gonna check your location. So that's not from the cell tower. That's from your GPS location on your phone. So once you agree to the weather app, so we'll check your location. So this data from that kind of this is permission-based data collection.
I see.
So again, the cell phone location shows where people are inside of Yellowstone. And interestingly, we compared the cell phone signal with this official stats in Yellowstone. See, because we know the people visiting this Yellowstone Art Photography Center, that's the most popular place inside of Yellowstone. That's right beside the old geyser, old faithful geyser. The most famous geyser, right? So there's a building beside that. So that's art center. You can buy buy paintings, you can buy photographs. So when we compare with the two different traffic, so the orange line is the mobile phone data. The blue line is the gate traffic, the Yellowstone gate. Okay, that's the indication of was actual visitor. You can see there's a big change here. After July, end of July in 2020, you can see that diverges a lot. It shows more traffic at the gate, but less traffic inside of this most popular place. Why? When we talk to the people, we found the results because in 2020 they have this COVID-19 rules that only they limit number of people inside of this indoor place. You can see our phone data actually captured those traffic for a specific POI inside Yellowstone, which cannot be captured by the gate traffic. Now that's the benefit of the mobile phone data. You can capture in each POI specific location. Otherwise, you cannot know to capture. Or maybe the sender can capture through the sales, right? But the cell phone is another data source to capture the traffic to the place, POI. Yeah. So again, mobile phone data is pretty useful. As showing through these two examples. All right, simulation. Simulation is another big data source we can use. We did this study in the summer of last year. We went to Rocky Mountain National Park. So why this park? Because it's very popular. It's very close to Denver. There's a lot of people. And the more important, there's only one narrow road in and out, okay? There's only one way to get to the most popular place called Bear Lake. And there's a lot of fires in the west of the US right now. Fires, because lightning, because campfire. So the park people got really nervous when the fire happens because they had to evacuate people quickly, as quickly as possible when the fire happens. So we did an agent-based simulation for the evacuation. How did we do that? So we consider each car as give its specific behavior. Okay, we can see this car travel at this speed. More or less, you can give a range, and they follow this traffic signs. They can stop at stop signs. They can slow down when they go uphill. They can speed up when they go downhill. You can yield to different traffic. So we can put many cars inside this simulation model, right? To let the simulation model run. We can tell this model, okay, you have 1,000 cars in the park. Let's get out as soon as possible. Of course, we have confirmed this model with the real data. So we went to the park. We measured the car speed on the road. We actually played as a police officer. We measure the car speed on the road. So that's pretty fun. So then build this model. We can play with different scenarios. For example, we can say there's a car accident here. The car accidents stop the cars for say 20 minutes. Then how long it takes to evacuate people. So we use this model to simulate all the scenarios, right? So we can find out where people got stuck. You can see the road in red. It means there's a lot of people stuck on here. So then the park can do things, can implement some strategy to speed up people, the cars. Maybe put a park ranger there to direct traffic. So we can, if we can identify the place of congestion, we can do something about it. The thing is, we can run this model many times, 10 times, 20 times, 100 times. We can throw in many different scenarios: car accident, road construction. What if the road was blocked due to a fire? Where else people can go? So that will generate tons of data. So now we can see how long it takes to get out. What if people get out from this exit? What about another exit? What about half and a half? So using this simulation, we really can simulate one scenario which never happened before, to better prepare for emergency.
Okay. So the data is that the Colorado,
yes.
They providing this data to you. Population.
Yeah, they provided the traffic of how many cars in the park. They provide how many people on the hiking trails.
Okay.
We went to the park to measure some other data. For example, the speed of the cars, the speed of the buses, because some people take buses too.
Okay.
Yeah.
Interesting.
There's so many fires in the U.S. in the West. That's a big problem right now.
Okay.
Yeah. All right. So let's jump to the conclusions. How much time do I have?
40 minutes.
4 minutes?
40.
40. Okay, well, I have plenty of time. That's good. I want to leave some time for questions from the audience, though.
Sure.
All right. So later we did another study. Okay, we try to combine all this big data into one model. Okay, so we know search engine volume in data is valuable. Website traffic is valuable. Social media is valuable. What about we combine them together? Can we achieve very, very accurate forecasting? Actually, we couldn't. We found out that we reached a limit, just like a curve. We reached the upper limit because we can never achieve 100% accuracy, right? It's not possible. And many times those data are correlated. The search engine traffic data is correlated with website traffic data. And we can only achieve 97% accuracy. We can never go any higher than that. Also, when we talk to hotel managers, they only use very simple forecasting methods. They only use, let's say, last year's same time, plus a linear trend, because they know this year is going to be better than last year. And at this time of the year, maybe 75% plus 2% more, because the economy looking good, because the summer is coming, right? It works pretty well, and it's easy to understand. The model is easy to understand. More importantly, they say good enough forecasting is good enough.
Right.
If they can be 90% accurate, that's enough. They know they need to hire this many people for next week. They know they need to increase the price or decrease the hotel price for the next week. They don't need 100% accuracy.
Yeah.
If you give them more complex models, they want to assess. They want to send it. It's more trouble for them. So again, this is about the limitation of complex models. Many times we don't need very complex models. In the real world, good enough model is good enough. Also, the problem with big data is when we talk about all those data, and we haven't seen the Tourism Bureau report those data yet, right? Tourism Bureau will report probably hotel occupancies, probably number of visitors. They haven't started reporting social media, rating yet, or at least in the US, or their website traffic. And different data give you different stories. Many people tell me, look, who do I trust? Search engine give me different data set. Mobile phone data give me different data set. And who do they give me different story, different forecast. Who do I trust? They don't equal to the traditional statistics from tourism bureaus. Right? So there's not a single coherent story to tell if you have many big data sources. And also they don't share with each other. Google give you Google Trends. Cell phone company can give you cell phone data, and tourism economists or bureau give you traditional stats. And there's no way to know which one is accurate. And many times they don't share data with each other. There's a silo there. And also, it's more important to know beyond data. We need to know the knowledge or the insights. Many times, big data tell us correlation. Okay, we know hotel occupancy is correlated with such queries, but really, did such query cause the occupancy? Sometimes we find out, like hotel occupancy in Charleston is most highly correlated with one such query called baseball pants. Okay, so why baseball pants? We had no idea. Maybe because they follow same seasonality. Maybe people start playing baseball when they visit Charleston. So we only know the correlation, and we don't know what's the Caucasian relationship. That had to do with more A/B testing or experiment. Now you can do the causal relationship, and you can test whether or not this really caused the outcome. So that's limitation of big data. Also, we needed to know more easily understandable big data. I don't know if you heard about the story about this doctor from 1854 from London. How did he discovered the origin of cholera, like a disease? Basically, he mapped out all the places of death from this disease in this neighborhood. So he basically use a map. He put the dots on the household where they have a death because of disease. He figured out all disease is around this well in London. If we figure out that the well is the sources of this disease, so they fill the well and people stop dying. So remember, before in 1854, nobody knows about the virus, or people think that's the bad luck or some evil spirits. He didn't know about virus. There's the virus haven't been found out yet. He just used the mapping skill to figure out the location of the contamination of the disease. Here says, computer is not the key. Computer is not the key. The insight from human being is still very crucial. How do you tell a story? How do you visualize the data? Using hands, you can find the insights. So computer is not the key. Human insights, visualization is the key. One of the research we did is not me did, one of the professors in Penn did this study. He can translate your analytics page into personas. Okay? I showed you this in the web analytics. Who's come to my website, from where? Well, he can translate this automatically into these personas. Okay? Automatically, right?
Automatically.
Automatically. He can tell you that's a middle-aged man, that's a young woman. That's a black person in his 20s. See how easy to see this result on the right side instead of the study the data on the left. The picture on the right side it's more easier to understand. You can show this to your boss. Look, boss, here's our visitors. Here our market. He or she won't like the data on the left. That's too much data for him or her, right? So how to translate the big data into easier data, more stories, more faces, We want to know the faces. We don't want to know 0, 1, so we don't want to know male or female. We want to see those faces. I think there's still a long way to go to reach this stage. Make data more easily understandable, making more sense. All right. So today, when you go to the Google Flow project I told you about, you see that the website is already being shut down. The Google Flow is not there anymore. They're saying we're no longer publishing the results, right? Why? Because there's research published again in scientific report. Some study shows their forecast is inaccurate. It's not very accurate anymore.
Oh.
That goes back to Chumo's comments. People change their behaviors. People use, TikTok, using other different tools. This model is not working anymore. So that's why Google shut down the website. So that's the that's the limitation of big data. The model can only work for a time period. After a few months, after a few years, I'm sorry, you have to build new models. You have to look at the new behavior. Nowadays when you type in a query in Google, there's many query pop up, right? You can pick from a list of queries once you type in a keyword. That simple change in interface change the people behavior. So make the model obsolete. So it's no longer working. So that's the problem with big data is inconsistency in different sources. The ephemeral nature of big data is changing all the time. We need to move from data to stories. Move from data to easily digestible, understandable stories or faces or pictures. And in Nature, the published paper talking about we rely on algorithm. The big data from algorithm is flawed because many times, let's say Google Trends, we don't even know how they come up with the data. We don't know. They just show up the data. They have a lot of cleaning beforehand. How did they do the cleaning? We don't know. So that's dangerous if we totally rely on that data. And of course, there's some ethical concerns. For example, some courts in the US, they use some algorithm to predict if this person gonna be recommitted a crime. The other, for example, this person, this inmate, in prison, apply for probation, means they want an early release so they can get out, to work. The companies have this algorithm. They can predict this person gonna recommit a crime in the future. So some judges using this algorithm to predict this. Well, it turns out certain races are more likely to recommit a crime. Say, then the judge is gonna say, no, I'm sorry, you're not allowed to for probation because you have 95% of the probability to recommit a crime in 3 months. The question is that fair? Is this fair? Is this justifiable? Because I'm a person of color. Because in the history, my race is more likely to commit a crime, does not mean I will commit a crime, Is that a bias? Is that a discrimination? Nowadays, some company hire people based on your home location. If they find out your home is far away from my company, I'm sorry, I don't want to hire you. Because the model shows if your home too far away, you have a higher rate of quitting the job after let's say after a few months.
Wow.
I mean, is that fair to the job applicant? You know, I don't know if you heard about this target story. So this is another story. So
we look at the face.
What?
We're looking at face, and face tell us his fortune and her fortune and her preference, whatever. So we judge.
We judge by faces. Yeah.
By
yeah.
face.
Another type of bias. Yeah. So this story you targeted. So this story, if you haven't heard about this, so so targeting, you know, is a story in the U.S. I don't know if that's in Korea or not. The target is a store in the U.S. So one time, this manager is working in the store. A customer, like the middle-aged man, rang in and say, "I have to talk to your manager." Then the man, you know, yell at the manager. He pulled up a brochure. He said, "Look, how can you send this to my daughter? You know, this is about, you know, pregnancy. This is about baby's clothes. My daughter only 16. You know, how can you send this material to her? You send this material to her to our home, to her name, email. You know, how can you do this? How dare you do this?" So the manager apologized. "I'm sorry, this must be a mistake. You know, we sent this according to a certain algorithm. You know, so this must be a mistake." So he apologized. The man went back home. So the next day, the manager got a phone call from him, from the same person. He said, "I'm sorry, I didn't know my daughter is pregnant. I found out my daughter is pregnant. I'm so sorry. So I yelled at you yesterday." So the story says the algorithm of Target can predict if this person is pregnant or not, even better than than her father. Because with big data, you can predict a lot of things. You know, if this person buy this, you know, this product, this sensitive candle, they can predict this person is pregnant. Is that scary? That's truly scary. So the lesson is sometimes we don't need big data. You know, if you're being too accurate, this could be scary. There's a consumer's acceptance to this. You know, sometimes we don't need too precise. You know, sometimes it's okay to be a gray area. You know, to be unknown. You know, to pretend not to know. You know. Of course, targeted, you know, change their algorithm. You know, they won't do those specific targeting anymore because it's truly scary. All right, so I think that's it. I think, you know, I think the challenge for tourism is sustainability. I know we talk about this a lot, but I still think the crucial question to answer in tourism right now is sustainability. After COVID, I think travel will come back. You know, I'm sure it will come back. Will be more people travel than before. But the problem is, tourism contributes to 9-10% of CO2 emission. There's the planet is getting, you know, hotter and hotter. And many places in Charleston, actually, the downtown was being flooded all the time because it's in the ocean, close to the ocean. So that's the problem we need to deal with. I think big data can play a role there. You know, we're not using big data to study, you know, sustainability. How do we travel less? Maybe, you know, how to travel smartly. So, all right. So I'm talked enough. So let's see any questions here.
Okay. Wow, it's very good. And a very important point you tell us about the big data. Actually, we tend to trust on data because we learn from data, and we can justify based on data. But you said do not trust much. Okay. So anyway, data tell us the result and description of that fact. But however, we couldn't find out the motivation and the causality.
Yeah.
So that's we need complementary. We need add big data plus experimental design data to find out cause and result together. What do you think is so we need mixed method technology for forecasting the exactly between big data and the survey data and experimental data?
Yeah, I would think so. I remember that the paper published in the Journal of Marketing a couple of years ago. This professor using text message to do A/B testing.
Mhm.
So he set up a so he text people in the mall on their cell phones using geo-facing to figure out which is the best way to give people promotion. 10% off. Like something free. So it truly shows the type of advertisement can impact the conversion rates. So that's A/B testing. That's truly testing in the real world. I think that really the experimental design could be really useful in the future. And yeah.
Okay, so the beyond the big data, we need to conduct experimental design for finding accuracy, the motivation and the result. Well, okay, right. And students,
Amazon doing that all the time. If you're going on Amazon doing like 300 studies every day.
Mm-hmm.
Sometimes they swap this book with that book to see how likely you will buy that book.
Okay.
They do that all the time, because they have millions of visits every day. They can afford to do all the studies online, and this user results. If I put this picture here, I'm gonna sell more products. I'm gonna just put this picture instead of that picture. Yeah.
Because we are human beings and we are very emotional animal.
Yeah.
Okay, seriously, it's time for you to give your question to him. This is a very we are the big data era, so you need to ask him about the big data, how to handle data or how to conduct research using big data.
I think Yerin has a question.
Yes.
Okay, cool.
Okay, yeah, I have a question. Actually, my question is related to the transportation or geographic approach when we use the big data. And I think that there are many transportation infrastructure that are less accessible to tourists. And for example, in Korea, there are insufficient traffic hubs or complicated roads, and therefore many tourism papers says that transportation infrastructure should be expanded further. But however, as I know, the practitioners of transportation says it is very difficult to expand the transportation infrastructure, because not all infrastructure is fit for only tourism. So as a student, it is too challenging to talk about the practical implication when we study having a geographic approach using the big data. So I want to ask your opinion on how to increase the accessibility of tourists without the expanding infrastructure is. So yes, from the tourism's practical points. Yes, thank you.
So are you saying like the road is really costly to construct, right?
Yeah.
Yeah, that's a great question.
These days, she's the PhD students. These days we are doing projects. Analyze POI.
Yeah.
And POI announced by DMO. And then we also analyze the transportation route operating by province. But there exist gaps between DMO providing POI and the transportation public bus schedule, and then so there's huge gaps. So I find out that there is an accessibility problem between POI and transportation route. So we need to.
So are you saying that's only like maybe not paved road, like really elementary road, right? It's not like a hard surface road.
Road.
Yeah. I mean, that's a situation in a lot of parks in the US too, in a lot of national parks. But that's different, I guess, because in the US, they prefer hiking. You go to hike instead of doing road because they want to preserve the wilderness, the character of wilderness. They want the park to be wild, They think, more road actually is bad for the parks. Because that's human trampling, human, So are you talking about like the village, right? You going to a village or scenic area, or just like a waterfall or something?
The POI, point of interest, announced by DMO is including everything.
Yeah. Well, something like the national parks or the restaurant or the historical park or something, everything on the destination.
Yeah, you mean the road to those places are very basic, right? There's not good road.
It not just from road, but to public systems together. So public system is not accessible conveniently to the point of interest, as well as the road.
You mean the water or cell phone or
what?
Yeah, because Chumo said that the public systems. What do you mean public systems?
Bus. Bus.
Buses. Okay.
Yeah.
Buses.
Well, is there any way to make that a business? Maybe like the transportation itself could be a local business.
Yeah.
If no public buses, but how about private buses?
That's why I suggest private buses.
Yeah.
On-demand service we need.
Yeah.
Okay.
But that's like the chicken and egg problem, right? So in order to have people go there, you have to have a good reputation, right? If you don't have roads, it's hard to get into. Nobody want to go to that place, right? So where do you go first?
Yeah.
Yeah, I don't think there's an easy way to solve that. Sorry.
Okay, thank you.
Yeah.
Okay. The main point is the POIs is lack of transportation system connection. So tourism business must be provided to the accessible, vehicles.
Yeah.
Not only the private car or public buses or private, systems, whatever. So we try to figure out that issues. There must be big gaps, POI, and then accessible transportations.
Well, if you do a good job in promoting the place, show how beautiful it is, then more people will come. And more people come, then you may have a business model where you can have a company to provide those service.
Mm. Okay. And the next. No. Okay. These days, okay, go.
Sorry, I have a question.
Mm.
So when you mentioned about the using big data for the flight industry, you mentioned a lot of data sources like populations and like driving distance, right? So I was thinking if you considered the big transportation companies, like for example, in the United States, there are a lot of big bus companies like Greyhound and Megabus. So when I was in there, I thought that's really good alternatives for flights because I can save money while I can take rest. So I was wondering if you considered that.
Yeah, that's a great question. We because we're doing a survey every year, we survey people, how do you come to Charleston? Very few people use buses, very limited people. I think most, like 60% of people are driving, 20% people are flying. There's some people actually take a boat there because sometimes they have a private boat. Very few people take trains, and even smaller people will take buses. So that's only, I think, a small market for Charleston, because Charleston is a pretty expensive place, and very small population. But again, we could consider that, but we didn't, because there's maybe the weight is very few, very small. So that's a good question.
So maybe it can be related to their incomes, like because like students use the bus a lot, and that's quite costly place.
So yes, I think our university's students use a lot of buses too. But that might not be our target market for Charleston. Yeah.
Thank you.
Okay. Any questions from students? Okay, Ping, you're originally from China.
Yeah.
And these days, Chinese companies and China, the country, they are providing or generating a lot of huge big data, and then those big data is given to the researchers for research. So these days, in general, they are really like Chinese big data, because the large volume of big data tells the new story. So what do you think about, because you have a connection with your hometown, home country, and you may have a chance further, more than any other people, utilize the Chinese big data. So what do you think? I work with people before on mobile phone data. Yes, you can get some mobile phone data. Yes, but I talked to Tencent, the company Tencent before. Mm-hmm. Tencent, they own QQ, they own WeChat. Mm-hmm. They have a pretty strict policy. Mm-hmm. So, for example, if you want to study QQ or WeChat, you have to have very long process of approval. Okay. And you can only see some data sitting in their office. You cannot copy the data out. I see. I think that's good, because they trying to protect the privacy of the users. Mm-hmm. Think about how many how many insight you can get from if you access to WeChat information. Mm-hmm. And I know in China a lot of people use WeChat for everything. Mm-hmm. Flight, buy stuff, everything.
So you know a person's whole life if you have get access to his or her WeChat account. So they protect this really strictly. So that's nice. That's good. Yeah. Mobile data. I worked with mobile phone data before, but you have to have a connection with the government to use the data many times.
Okay.
They are also very cautious not sharing much data because the texting message is very private. I mean, like even the video surveillance, the video surveillance data is everywhere in China. You can know so much about the cities, by video surveillance. Well, sometimes I'm hesitant to do study on that because the U.S. is very strict on those policies. So like San Francisco even banned the use of video camera in cities. Some cities banned the facial recognition in video cameras.
Okay.
By the government. The government is not allowed to use video cameras to capture faces and do the facial recognition. If I do research in China using that technology, is that ethical? So I'm still bounded by the policy in the U.S. Right? My university have certain policy. I have to follow, right? So I don't know. So maybe sometimes I don't think I should do study on certain things. Too private. Yeah, that's a great question. Yeah.
Professor,
Okay. Well. Okay. Go.
Hey, Ming.
Yeah. Okay. When you use the secondary data, like big data, I think it is hard to get exactly same data set with my purpose, unlike survey, because it is collected there on first purpose. So and also as a student, we can get data from only the getting data from company is really hard because the money or something. So sometimes we use only public data, and it also just provide limited data. So I want to ask, how can we connect the data itself and concept of our study? Is it enough to we just operate the definition by our those in writing papers? So I want to ask, sharing your experience or tips to us.
Yeah, that's a great question. Yeah, I'm sure you know this, right? Big data research is more likely to be a bottom approach. So we have certain data, we try to make sense of it. We try to extract some concept, but it might not be the variable we try to measure in our research. Absolutely. Yeah. Same like I think that's maybe different, paradigm. Is there a value in that? I think there's a value for bottom up approach. Many times we don't have a theoretical framework. We only have certain data. It's not exactly the same what we want to measure. For them with the mobile phone data, the way they define a tourist is different from my definition of tourist. For in the U.S. case, if you stay more than half the time in a month in a location, they think that location is your home. So another location is not the same city. Is your place of travel. That might be true. It might not be true because sometimes you stay in a hotel for more than 2 weeks. But that's as far as they can go, because they only know the location of this cell phone device. My answer is I don't have a good answer to your question. I think that's the question that big data researchers are facing. That means again maybe you go back to the experimental design, right? So maybe you should start doing experiment so we can control the variable we try to measure. That means we had to work together closely with tourism bureaus, for example. Work with OTAs, online travel agencies closely. That's need a lot of connect to make. Like Chumo may need to work on those connections. How do we work with cell phone companies, or OTAs? That's what's the boss is working on, making connections. Yeah,
Right.
that's a great question. Yeah, that means you understand big data. That's a problem.
At least Hemin's question is she understanding
Yeah.
Big data issue.
Yeah.
And the research and practical data gaps.
Yeah, that's a gap. Yeah.
At least the kind of basic understanding is very, very knowledgeable, actually.
Mm-hmm. Yeah. Good. So you're asking good questions.
Okay, and time is up. There being Professor Being also as 1 minute left. Why don't you say something addressed to our students about your opinion and whatever you want to say?
Oh, okay. So actually, I can give you a story to tell. Okay. Okay. This is not to do with research. This is about life. Okay. So I'm 48 years old, right? So the life expectancy of people in the U.S. is 78, 79. So I'm past the half points of my life. Chong is much younger than me. Chong is much younger, right? I'm older. So
really, I'm over 50.
No, you look much younger. So when I'm this age, I can see the horizon. I can see the end, right? I can see the end of the line. You guys are very young, right? You cannot see the end. Your life is without limit. Your field is wide open, right? So when I'm reaching 48, I have an epiphany. So I have like sudden realization. So for example, in the past, when I'm eating a dinner, right? So say I have like some steak, I have some good food, I have like some vegetables, like spinach. In the past, I started with the vegetables. I eat the spinach first. I eat the better things first, and I leave the steak at the last. I eat the best thing last. I don't know how you eat, but that's where I eat before. So after 48, I go for the best thing first. I go eat the steak first, then spinach, then the vegetables. Why? Because you never know how long my meal gonna last. I may have a heart attack right there. I will never reach my steak. That will be a regret. I want to go for the best food first.
That's right.
Right? Let's go for the best first. So from now on, everything I do, I go for the best. Okay. If I have 2 hours to watch a movie, I want to watch the best movie available. If I have several projects to work on, I want to work on the best project. Right? Because I have limited time. I don't know how long my life gonna last. I may, have a heart attack. If I want to talk to some students, I want to talk to the best students like you guys. Right. Go for the best. Live every day like your last day.
Oh, that's right.
Right. Yeah. All right.
The philosophy of Professor Bing Penn is the go first, the best.
Yeah, go for the best.
That's right. I'm highly appreciative for your attendance and your great lecture for us, and I look forward to see you in the conference. I may visit Washington DC I agree. If you get
I agree. When is that? When? What time?
August.
August. Okay. Let me think about it. Okay. Yeah.
Okay.
Yeah. Hope to see you then. Yeah.
See you there.
Yeah.
Okay. See you, and thank you very much. And
thank you.
Thank you.
Yeah. Have a good day.
Good day.
Bye. Enjoy.
Good night.